or the big eye of the superstorm, is rapidly sinking, and it's sinking so fast that it's bringing down supercooled air from the top of the troposphere. So, what do you guys know about adiabatic cooling and warming, and is it actually possible for rapidly sinking air to freeze?
No.
What happens to air as it's sinking?
It heats up.
It warms. Based on adiabatic cooling and warming, sinking air will always warm and rising air will always cool. So the premise of this movie is entirely impossible because that sinking air, it doesn't matter how fast it's sinking, it is going to warm as it sinks. Alright, now let's go to our air parcel going up and down the mountain. This is something that you guys probably going to want to really be paying attention to because there will be homework and exam questions on taking an air parcel up and down a mountain. So we start out with our air parcel. Temperatures, 30 degrees, dew point 10 degrees. Is that air parcel saturated or unsaturated?
Unsaturated.
Unsaturated because these two numbers are definitely not equal to each other. So, as this air parcel is rising, is the air temperature, the 30 degrees, going to cool at the dry or the moist rate?
Dry.
And what is the dry adiabatic rate?
10 degrees.
10 degrees per kilometer. Will our dew point also cool or will it stay the same? It stays the same. So at 1 kilometer, now our temperature is 20, our dew point is still 10. Saturated or unsaturated?
Unsaturated.
It is still unsaturated. So that means that we're going to have the exact same thing. Temperature is going to cool down at the dry rate, dew point is going to stay the same. So now we're at 2 kilometers. Temperature 10, dew point 10. Saturated or unsaturated?
Saturated.
It is saturated. Here's where things get tricky. Our temperature, is it going to cool still at the dry adiabatic rate, or now will it cool at the moist adiabatic rate?
Moist.
The moist rate. And what is that equal to?
6 degrees.
6 degrees. For our class, 6 degrees per kilometer. How about our dew point? Is it still going to not change?
No, it all
Will it
changes.
cool at the dry rate or the moist rate?
Moist.
Alright, so the temperature and the dew point, both of these 10 degrees are going to cool at the moist rate. So now 4 and 4, still saturated?
Yep.
Still going to cool at the moist rate?
Yep.
Yep. So at the top of our mountain, our temperature is minus 2 degrees and our dew point is minus 2 degrees. Now, we got to take it down the other side. So, the first one's easy. We're at the top of the mountain. So we're just going to transfer those numbers over. We're going down the mountain. Will our temperature be warming or still cooling?
Warming.
Yes, as we just talked about, sinking air warms.
Be 8.
And will our temperature, here's the part where it's really tricky. Our air parcel's saturated at the top of the mountain. Does it stay saturated once it starts sinking? No, it instantly becomes unsaturated. So that's the tricky part, is instantly, as it goes down, 3.9 kilometers, it becomes unsaturated.
Does the dew point stay the same?
So, we'll get to that.
Oh.
Our temperature, is it going to warm at the dry adiabatic rate, or will it warm at the moist adiabatic rate?
The dry rate.
The dry, because it instantly becomes unsaturated. Will our dew point temperature warm as well, or will it stay minus 2 the whole way down the mountain?
It'll stay minus 2 the whole way down.
Yep. So our temperature will warm 10 degrees.
I knew this.
Our dew point's going to stay minus 2.
It's crazy. 18,
You
28.
keep, nope. You keep going down. It's going, I'll figure out like what points you guys get later on. Still staying the same. The dew point still staying the same the whole way down. Our temperature keeps warming at 10 degrees for every kilometer that it goes down. So we end up at the surface, the temperature's 38 and the dew point is still minus 2.